Hello children, in this video we are going to learn about trigonometric identities, which is of great importance in the chapter trigonometry. So let's write down the three trigonometric identities which we are going to use in many of the questions, or I can say in most of the questions of our next exercise. We will see the proof of all these three trigonometric ratios also, and it's very simple to do it. Let's see the trigonometric identities and its proof with me. So here I have written trigonometric identities. Identity means equal to 1. So whenever the things are equal to 1, then we say it trigonometric identities. And yes, it includes trigonometric ratios. That's why it is known as trigonometric identities. So we have first trigonometric identity as sine square theta plus cos square theta equal to 1. That means here sine square theta means sine theta whole square plus cos theta whole square equal to 1. If it is whole square, it can be written like this, cos square theta equal to 1. So this is our first trigonometric identity. See the second trigonometric identity. It is sec square theta minus tan square theta equal to 1. And the third is your cosec square theta minus cot square theta equal to 1. Children, you can learn in another way also. Here you can write it as sec square theta equal to 1 plus tan square theta. You can learn in this form also. But since I have written identities, so you remember it's equal to 1 form. Okay. So these are the identities which you have to remember. These are the identities which you have to remember wholeheartedly. Okay. Now let's see how we can do the proofs of these three identities. So first of all, let's take a right angle triangle. Let's say this is A, B and C, and let theta is defined over here. So whenever a right angle is given to you, you can always apply Pythagoras theorem. So by Pythagoras theorem, what I can write here? I can write AC square equal to AB square plus BC square. AB square plus BC square equal to AC square. Now children, this is the Pythagoras theorem you are getting here. Now to do the proofs of all the three identities, what you have to do? First of all, let's suppose I take AC. Okay. So you divide this complete equation by AC. If I divide this by A square equal to AB square plus BC square, if I am dividing this by AC square, then what will I get? AC square by AC square by AC square. AC square and AC square gone, so this is equal to 1. Now this can be written as AB by AC whole square, because this square means side AB square, square of side AB. This is square of side AC. So this square can be written as common. This will be your BC by AC whole square. Now children, you see, if this is your theta, then this is your perpendicular. If this is your 90 degree, this is your hypotenuse, and this is your base. Now here it is given AB by AC. AB, that means perpendicular. What is your AC? H. So AB is what? Your perpendicular, and AC is what? H. And you know P by H is what? Sine theta. So here in place of AB by AC, that means the ratio of AB and AC is sine theta. And here it is given whole square, so it is whole square. Plus what is BC by AC? BC is what? Base. Base by hypotenuse, you know that this is your cos theta. BC is what? BC is your base and AC your hypotenuse. So ratio of base to hypotenuse gives you cos theta. So I can write cos theta over here, or simply I can write it as sine square theta plus cos square theta. So this is your first identity which you have proved very easily. Children, always remember this square doesn't means square of the angle, but it is the square of complete sine theta. That's why I have written sine theta whole square. But yes, in trigonometric ratio it can be written as like this. But always remember, whenever you are writing it like this, it doesn't mean that you have to make square of theta. Fine. Now let's see how we can do our second or third proof. The same thing we are going to use. Here it is given to you AC square equal to AB square plus BC square. I have written it again. Now once I have divided it by AC square, now I will be dividing it by AB square. So dividing it by AB square, I am getting it as AB square by AB square by AB square. Okay, so AB square and AB square gone, so it is equal to 1. Now what is your AC by AB? AC is what? Hypotenuse. What is your AB? It is P. So AC is H, AB is given to you as AB is P. So H by P is what? You know P by H is sine theta. So H by P, that means reciprocal of H by P will be what? Cosec theta. So in place of this I will be writing cosec, and this is given here square, so I will be writing it as square. AC by AB is cosec theta and it is square, so I have written square. BC by AB, BC is what? B, and AC what? H. So B by H, what is your B by H? Remember it by the formula Pandit Badri Prasad Har Har Bole. So B by H is what? You can say, here it is given to you as BC by AB. That means base by hypotenuse. And you know your base by hypotenuse is, it's not hypotenuse, it is given AB. So base by perpendicular. Base by perpendicular is what? It is your cot theta. So here it will be, this is 1 plus cot theta whole square. So I have got this identity over here. If I want to make it equal to 1, I can bring this cot square theta to my left hand side and I'll get the required identity. That means cos square theta minus cot square theta equal to 1. So this is the proof of my third identity. Now see for second identity. Once I have divided it with AC, once I have divided it with AB, now I will be dividing it with BC. So I am just removing this from here and let's see the proof of the last identity. That means I am writing it again, AC square equal to AB square plus BC square. So divide it by BC square. So BC square, BC square and BC square. So BC square and BC square gone. So here I will be getting as 1. Now this is AC upon BC. AC is what? Hypotenuse. BC is what? BC is what? Base. That means this is hypotenuse upon base. And hypotenuse upon base is what? Reciprocal of cos theta, which is your sec theta square. So in place of this I have written sec theta square equal to AB. AB is what? AB is what? P. And what is your BC? B. P by B. P by B is what? Tan theta. So I am writing it as tan theta, and since it is square, so I am writing it as square. I can frame it like this: sec square theta, tan square theta can be taken this side, and this gives me equal to 1. So this is your third identity. Isn't that these proofs are simple? What you have done? You have just drawn a right angle triangle. You have marked theta. By Pythagoras theorem you have written this, and then once you have divided it by AC, then by AB, and then by BC, and then you have got all these three identities. Now children, these are the simple steps how you can prove these three identities, although these proofs are not asked in the board, but sometimes yes, board can ask also. So you have to remember these three identities by heart, because we are going to use these identities in most of our questions. So let's have a look over here and remember.